afternoon. Unprepared as I am, I wrote my notes because I can't see the video. So welcome to the IP Connected Media Red Carpet treatment. My name is Malik. I'm with LTN. I'm the chairman and co-founder. And thank you for making the time to sit and listen. I'm going to talk a little bit about and try to demystify a little bit about what the internet looks like. I'll talk a little bit about why media customers like you guys are, I think, starting to think about transitioning from traditional satellite distribution to IP-based distribution. And then what are some of the pitfalls that you need to watch out for, plan for, think about, and hopefully this will be helpful to you from that perspective. And of course, I'm going to talk a little bit about LTN as I go through that. Let's see if this works. So let me environmentally talk a little bit about what I think many of you should probably already know this better than I do. But it gives context to my presentation, so I'm going to be a little redundant, and I'll talk a little bit about that. There are some significant challenges facing the media industry, and there are two significant ones that I'm going to talk about today. One is competition from new entrants. You know, FANG, we all know Facebook, Amazon, Apple, Netflix, Google. There's an enormous amount of money being spent on new content by new entrants. Much of that content is available on the web, and only on the web sometimes. But the amount of new content being created is enormous. Netflix alone is planning to invest $15 billion in 2019, up from $12 billion in 2018. Facebook, Apple, Amazon really aren't that far behind. YouTube is catching up very quickly to those numbers. So from a traditional media company perspective, this is a very big competitive change in the landscape that they have to adjust to. As if that wasn't enough, the second major change is technological and consumer behavior change, where you now have to deliver content to literally everyone in the world, in any device they might carry, connected to whatever network they have, and consumers now want that content available on any device, at any place, at any time. So for media companies to be able to create the infrastructure to be able to deliver all that content is not for the faint-hearted. I mean, there's a lot of, and at the same time, the amount of investment required to do that is really climbing because new technologies are emerging, and each of these technologies has an obsolescence risk, and each of these technologies also has an issue with skills in-house. You know, are the people ready for that? So lots of challenges in that area. So the days where, you know, we could have one channel, send it up on satellite, and anybody who wants it can go get it from satellite. Those days, I think I'm not being too aggressive in saying this, but I think those days are coming to an end. The new world requires customization, personalization, regionalization, all of which require the ability to distribute in a very flexible way to any audience, anywhere, different types and different forms of content. And there is really only one resource that's available that has the scale and ubiquity to be able to substitute for the satellite business-to-business infrastructure, and that's the internet. And the issue with the internet is that while it is one of, I think, mankind's great achievements, in terms of connectivity and reliability of communications. It was never designed for time-sensitive or delay-sensitive traffic. So we're going to talk a little bit about that. So before I do that, I'm going to just set the context a little bit and just put some facts down that are sometimes lost in the shuffle. For one thing, there is no internet. There is no such thing. There's no headquarters for internet. There's no email that you can send to the internet. There's no phone number. The internet is a loose confederation of over 60,000 individual networks. These networks have a hierarchy, and within that hierarchy they have certain roles that they play, and they all have one thing in common, which is that they were architected to be fast, scalable, and reliable. They are not architected to be smart. They don't care. The internet does not care. None of the protocols care what they're carrying or have some kind of policy-based infrastructure that does different things with different packets. It's built to be a common resource, and it gets the traffic to the other end, but there is no guarantee of time. Intelligence in the internet is assumed to be at the edges of the internet, not in the middle of the internet. So I'll just talk a little bit about hierarchy and then get to the issue. So there are 3 tiers. There are tens of thousands of tier 3 carriers. There are hundreds of tier 2 carriers. And there are 13, last count, tier 1 carriers in the world. Each tier can communicate within that tier in a peering arrangement, except for tier 3. Tier 3 doesn't really peer with other tier 3 carriers. If you have a tier 3 carrier at your home or business, and you are trying to get to a resource that's on another tier 3 carrier, you are most likely transiting up to a tier 2 or tier 1, and then down back to the other tier 3. There is no direct peering between tier 3 carriers. So built right in there is a kind of an going upside and then down, kind of an infrastructure. Each time a lower tier guy goes to a higher tier guy, he pays money. It's not a free transaction. It's called transit arrangements. Tier 3 carriers all must peer with all other tier 3 carriers. So once you're on a tier 3 backbone, you literally have access to everything. You are able to peer with everybody. Those peering arrangements are commercial but non-financial. They're basically built on the concept of, hey, I'm going to give you a terabit per second of traffic, and I'm going to accept a terabit of traffic from you, but don't give me more than I'm giving you, okay? And if you do give me more than I'm giving you, we're going to have a problem of congestion and delay and queuing, because I'm not going to serve it out at any more than the rate I agreed. There are private peering arrangements, and I'm not going to discuss those right now. These are for the public peering arrangements. Within those networks, how do you get these 60,000 networks to work together to create the internet? Well, there are 2 things that they all have in common. Thing number 1 is they all run the same protocol intra-network, inside their own network. It's called OSPF, Open Shortest Path First. And it does the shortest path count by hop count. It says how many hops between ingress and egress, and that's all it cares about. It doesn't care about any routing infrastructure, any intelligence to do specific things to any traffic. Then the networks connect to each other via another standard protocol called Border Gateway Protocol, BGP. That's it. And BGP works on the same principle, shortest path to the destination. Okay? So you have 60,000 networks, all of whom are trying to find the shortest path between them all to get your traffic from your client to your server, from your server to your client. Okay, but I just told you there are peering arrangements. I told you there are transit arrangements. I told you there are aggregation arrangements. What happens when you have a congestion at a peering point, at a transit point, or at an exchange point? Nothing. Internet cannot route around that. You wait until you either get your packet through or your application times out. Okay? So when you as media companies are looking to go from satellite distribution to internet-based distribution, these are things, architectures and protocols and hierarchies that you must contend with. And you cannot do any of the resolution of this from the edge of the network, because these issues are inside the network and they're architected to be inside the network. So now I can introduce the LTN network to you and why we are different. Why do we have, customers like Disney and Turner and YouTube and Hulu and just about every tier 1 media company, and now all the tier 1 OTT companies. Why are they using LTN to transport their traffic? Why are they coming off of satellite onto our network? Well, there are some very key things that we have done that mitigate some of those architectural issues I talked about. The first is we have a network. It's a global network. It's on 3 continents. It's made up of data centers, which are very large facilities where we have the ability to put up to 40 racks of intelligent servers, providing many different functions. So first is we have invested in a massive network that's a global facility at our cost. Then next we buy in 10 gig chunks, gobs of capacity from half the tier 1 carriers in the world, all of whom are available to us at every data center. That allows us the opportunity to arbitrage. But to do this, you have to have an infrastructure, you have to pay somebody, you have to pay the tier 1 carriers, and now we are able to peer directly onto the internet backbone, the tier 1 backbone. So that's number one. The second, we created an architecture that is a flow-based architecture. Internet, as you all know, is a packet forwarding architecture. It doesn't care what the packets belong to. What we do, our customers do. To them, this is not just, somebody playing a cat video on YouTube, okay? If I have, a channel like Showtime on our network that goes over the internet, they want that particular channel to go to a specific place with some degree of accuracy and reliability that is not available elsewhere. So what we do is we track all flows and we associate packets that belong to those flows inside our data center. So there is intelligence in those racks of space that recognizes the flows. There is a messaging system that keeps all of the flows and information on policies for those flows synchronized between all the data center. I mean, for technical guys, they would say that's a stateful network. And the state is what is this flow, what are the policies that govern this flow. Those are all kept in real time, and every data center and every piece of intelligence that we have knows about every flow, regardless of whether it's inside that transit path or not. Third, by investing in multiple carriers, we have the ability to route around any issues that we see. Every 75 milliseconds, we have patented software that interrogates every link in the chain from a source to all the destinations that flow is going to. And every 75 milliseconds, the network is routing around any issues with jitter, any issues with increased delay, any issues with loss, and is doing this automatically, thousands and thousands of times an hour. And the net result of it is that the customer gets their traffic routed around any of these issues within a very tight delay budget and with very, very high degree of reliability. Could I ask you to play that video, please? So this is a very pictorial depiction of what's happening here. We have a feed coming from the client on the right, or my right, or your right too as well, and going to the client on the left. It goes on the red carrier. I've depicted 3 carriers here just as an example. Goes on the red carrier to the first data center, then goes on the red carrier to the second data center because the network says, hey, this link is fine. Then when it gets to the second data center, it sees issues on the red carrier. Those issues could be early queuing issues. So there's no delay yet, but we see a queue developing. We will route that traffic off of red and onto the blue carrier in this example, and so on and so forth until it reaches the end. We call this dynamic multi-carrier routing. You don't have this, you cannot route around issues inside the internet. It is not possible to do this from outside. This is some real-world data that I'm sharing with you. This is the first time we're sharing this information outside our company. It's an average month in the life of our network. They have 1,800 full-time channels, 6,600 events that we do each month. The percentage of the feeds that are rerouted inside our network is over 1/3 of all full-time channels are rerouted on our network for at least 36 hours a month. It has to be at least 5% of the month for us to record that as a reroute. This is real data. This is what's happening in the network today. For occasional use events, it's a lot less because the duration is shorter, so it's 9%. And the average number of paths that the traffic takes is 2.5 for full-time traffic and 2.25 for occasional use traffic. In the face of that algorithmic correction, from a customer's perspective, what a customer sees is 6 nines reliability, and we deliver traffic from anywhere in the world to anywhere else in the world in less than 200 milliseconds. And that's what's unique about what we do. We have, beyond performance, there are a few other things I'd like to mention. We are a multicast network. We deliver feeds to thousands of endpoints from a single source. We have a lot of investment in security and delivering content safely. We're fully managed, not just automatically managed. We have human beings that watch and monitor every feed on the network on a 24/7 basis, and we're standards compliant. Regardless of what you choose, what format and encoding you choose as a company, we will get your traffic there. One last slide. We're not resting on our laurels. We have all of this intelligence and capacity for intelligence baked into our network. We are starting to now add best-in-class workflows that allow us to do post-production, allow us to do things like transcoding, standards conversion, closed captioning, video on demand, archiving, graphics, and ad insertion. Because the traffic is on our network, it's in real time, it's 200 millisecond delay budget. We can perform a lot of functions in situ, inside that network without having to yank it out into a batch process and put it back in. We're also improving connectivity for customers. There's a lot of customers for live view, a lot of customers that have SRT. And we've worked with LiveView, worked with the SRT consortium to allow access into our network. So in the case of LiveView, we have LiveView servers in our data centers. In the case of SRT, we are able to terminate SRT into our network. So regardless of what decision you've made for the end equipment, we will be able to give you the ability to connect to our network and enjoy all the advantages that I talked about. And as I said, everything, not just the network, but also the workflows, are fully configured, fully managed, and fully monitored with an expert staff 24/7. We want to outsource the things that our customers don't have the time, the resource, the capital, or the priority to do, but are important things for them, can increase their revenue, increase their profitability, increase their stickiness with customers. And we want to be able to provide that value and leverage our network. So that is my presentation. Thank you very much. We are in booth right there. I know we don't have time for questions here, and I know some of you will have questions of us. I'm going to make my way over there so you can intercept me on the way, or you can come meet me over there. And thank you for your attention. You've been a very patient audience. Thank you.